This is Math 2, second semester, final review. We did first part of Unit 8 yesterday. We're going to continue working with Unit 8, so if you'll flip over to this page here. I told you guys I would save 7 for today. Are we all ready?
Oh no, I'm almost ready. Yeah, this is crazy.
Guys, this one has a lot to it. So you want to definitely make sure you are writing the stuff down, you're paying attention, you're trying your hardest to understand it so that you could go back and do something like this on your own. Select all the expressions that are equivalent to this. So there's maybe more than one right answer. Now, what I'm going to do first is at least clean this up. Does everybody agree there's an exponent of 1 on that 8? And because there's no plus or minus signs, what am I allowed to do with that exponent? Distribute. And I multiply. What's this at? And I multiply the powers. I don't do 8 times 2/3. I do 1 times 2/3. So it's 8 raised to what power? Come on, guys.
It's to the third.
To the 2/3.
Yeah, that.
And then x, and what do you do with the power to a power? We just said it. No, we don't add. We
Divide.
not
Subtract. Multiply.
multiply.
Isaac, come on.
All right, so multiply.
Where's Jake?
I don't care.
He was on the.
Guys, remember when you multiply fractions, you multiply the numerators, you multiply the denominators. No common denominator is needed.
I say save.
Yeah.
I told you guys yesterday we were going to save it for today, and we skipped it and did this one yesterday.
Yeah, I had it.
Okay. So what's 2/3 times 2?
4/3.
4/3. All right. So first thing I'm going to do is, do I see an answer that looks like this anywhere here? Okay. Next thing I'm going to do is ask, can I simplify 8 raised to the 2/3?
No.
If we were to try, I would rewrite it in radical form. Would you guys agree with that first?
Yeah.
And if I did that, what goes where? What goes here is
Three
the
goes outside and 2 goes inside.
outside, meaning the power? Is that what you're saying? What goes in the power?
The 2.
And the index goes here?
Yeah.
Okay. So it doesn't matter the order. What is the easiest to do?
I don't know.
The radical, especially if it's a perfect squared or a perfect cubed. In this case, is 8 a perfect cubed?
Yes.
What's the cube root of 8?
2.
And 2 squared is 4. So it's 8 to the 2/3, which is equivalent to 4x to the 4/3. Okay. Is there anything that looks closest to this? A 4 on the outside, that's these two. And then x to the 4/3. Is this equivalent to that?
Yeah.
Yes, x to the 4/3. All right, so D for sure. Okay, after that, we're going to go through each one and check. We're going to rewrite them because there's different ways you can write these. All right, letter A. I am going to first distribute cube root of. Because the squared there is in parentheses, I'm going to distribute. Do I do 8 times 2 or 8 squared?
8 squared.
8 squared, and then x squared squared, you multiply, that's x to the what?
4.
Do we all agree? Okay, this is the cube root of, what's 8 squared?
64.
64 x to the 4th.
Crazy.
Still doesn't look like what we're looking for. I'm going to rewrite it. 64 x to the 4/3. No one's going to stop me?
No, oh wait, you gotta put the.
I messed
Where did you
up.
mess up?
You have to do it.
Yes.
You have to put 1/3 on the 64.
Good job. Okay, remember, if it's in the radical, it should have a power when I rewrite an exponential form. So he said this is a 1 and write it as the 1/3. Do you guys remember that? Yes, yes, you'll need to know that. Okay, is And you didn't have to rewrite it. If you could have looked right there and said, oh, 64 is a perfect cube, that's perfectly fine. What is the cube root of 64? The cube root of 64? The square root of 64 is 8. The cube root of 64 is 4. 4x to the 4/3. Is that what I originally had over here? So would this one match? Yes or no? Yes. Okay. So let's now try letter B. 8x to the 4/3. How do I fix this one? 8 to what power? 1/3, because there's a power there. 8 to the 1/3 is the same as the cube root of 8. Would you guys agree with that?
Yup.
And that is a perfect cube. What is the cube root of 8? 2. So this leaves me with 2x raised to the 4/3. X to the 4/3 matches, but this is 2 and this is 4. Are those equivalent? Yes or no? No. Close, but it is not the same. Okay, letter C.
We're still on it.
Yeah, Isaac, I warned you ahead of time. This is a longer problem. You want to make sure you're paying attention, which is why we saved it for today, because there was not enough time yesterday. All right, let's do it. Okay, now where are we at? C. A lot of kids will look at this and like, no way, it matches up. You have to be careful because there's an X on the inside, on the outside and the inside. So that gives me 4x. Do you agree that's to the first power right there? And then the one inside, when I rewrite it, it's x to the what fraction?
1/2.
1/3. Does everyone see where the 1/3 is coming from? Power of 1 and the index of 3. All right, what should I do here when I'm multiplying like bases? What do I do with the exponents?
Add them.
Add them is correct.
Add them, yeah.
Do you need a common denominator?
No,
Yeah?
no. Yeah.
It's really easy when you're adding 1 though, because is 1 equivalent to 5/5 or 3/3 or 6/6? What fraction should I use in this case?
3/1.
3/3, because 3/3 is 1.
3.
What's 3/3 plus 1/3?
2/3.
Be careful, not minus. Plus 4/3. So 4 stays 4, x to the 4/3. Match or no match?
No matter.
Match. Do you guys agree it matches? Okay, so we have A, C, D, and what's the last one to check?
E.
E. Okay, so let's check it. When I rewrite it, and we've done a few of them already. Oh, E, yeah, because we've already done D. Okay, 2x to the 4/3. What power do I put on the 2?
1.
2. There's a 1 in here, so when I rewrite it, it's 2 to the
1/3.
1/3. Is that equivalent to the cube root of 2?
Yes.
Now, is the cube root of, is 2 a perfect cube?
No.
No. I can't simplify this any further. This is it. Are these two things the same? X to the 4/3 matches. This is 4. This is a cube root of 2. Is 4 equal to the cube root of 2?
No.
No. Are they the same? No.
Wait.
So A, C, and D. Questions?
Are
Yes.
all these units going to be on the test?
Wyatt. It's all a second semester. And I'm giving it to you, entitling it final review packet. Yes. Okay. All right. Number 9. Do we need to see number 9? Yes or no? No? We're good on 9? What do you do with the 1/3 and the 1/3? You do 1/3 times 1/3, which is, we're multiplying here. We add exponents eventually, but what do we do with the 1/3 times 1/3? We multiply. Be careful. 1/3 times 1/3 is 1/9. And then x to the 1/4 times x to the 2/3. Guys, up here. Now, somebody said something about adding. Is this where I add the exponents?
Yeah.
What do you have to find first?
Common denominator.
All right, so you guys are doing that now if you've not already done it.
That was light work.
Good.
Look at that.
You said it's like word.
I think Vader? I am. Like this. Be the homie for the gang, I guess for the joke.
All right. Knock it off.
Oh.
Yes. All right. Okay. Next one, 10. Do we need to see? I'm assuming you guys did number 9 okay? Let's see, 1/9. Yes, the final answer is C. Does anybody need to see it?
Oh.
What is this? Once you add 1/4 and 2/3, those of you that did it,
Then
common
you get,
denominator.
You get,
It's 12.
you add the 3 over 12 and 8 over 12.
Okay.
Then you get 11 over 12.
Okay. So 1/9 x to the 11/12, and it doesn't look the same, but is it the same?
Yeah.
X to the 11/12 and the 12th root of x to the 11th power.
It's just in that.
Different form. Radical form. Radical form, exponential form. Okay. I will start you off on this one. When you distribute the 8 to the 1/3, I'm going to change this one to 8 to what power? And the reason I'm changing is so I can add the exponents because they're like bases. Plus 8 to the 1/3 times 8 to the 2/1. Okay, we just said it. What are you going to do with these exponents here? And are they already a common denominator? What are you going to do with these two exponents here? Are they already a common denominator? No, do that now. Common denominator between 1/3 and 2/3 and add them up. Wyatt, I'm going to ask you, so make sure you're doing the work. Right now, you should be doing 1/3 plus 2/1 common denominator.
The common denominator is. What is it?
3. So that stays 1/3.
Yeah, and then it's 2 over 3, right?
So we multiply
Oh, no,
top
6 over 3.
6 over 3. So what's the power?
7 over 3.
All right. Now, I believe we talked about this yesterday. Instinctively, you don't look at answers. What would you do right here with a 3 over 3? Do you agree? I would. I would call that just 8 to the 1, which is 8, plus 8 to the 7/3. Kids will say, oh, you can add them. They're not like terms. You add exponents. Please knock it off, guys. You add exponents when you're multiplying like bases, not adding like bases. But when you look at your answer, did they reduce it? Yes or no?
Yes. No.
Did they leave it as 3 over 3?
Oh, yeah.
And they didn't leave it this way. They wrote it in radical form. Which one is it?
C.
C. The cube root of 8 cubed, which is just 8, and then 8 to the 7/3. All right, and you would do the same thing again here. 5 to the 3/8 times 5 to the what?
Hold on. 7
1 half.
I'm right here.
2/4.
2/4, which does reduce, or you just know you're going to add, which means you have to find a common denominator. You can do that on your own. Do that right now. 3/8 plus 2/4.
4 over 8.
He is correct. 3/8. What does this become?
That's 4 over
4.
And so you add them. And do I multiply the 5 times 5, or does it stay 5?
Stays 5.
5 to what power?
7 over 8.
What answer? D. Okay. Do you guys need me to go over this rational, irrational stuff?
Yeah, we do.
Okay. It's been a while since we've done one like this, but just yesterday we reviewed rational and irrational. Do you guys remember that? For example, this 2 that I'm pointing to, rational or irrational?
Irrational.
Rational because there's no radical.
And then that one's rational too.
This one's rational. What about root 2?
Irrational.
Root 7?
Irrational.
2 root 7?
Irrational.
And 2 minus root 7?
Rational.
It's one number. 2 minus root 7 is irrational. Right?
My bad.
Okay. So, Multiply them, it's irrational, and when you add the same two numbers, it is rational. I'm going to focus on the adding piece first, because if I want to add two numbers and they come out to be rational, you have to really think about it. First off, does everyone agree if I picked 2 and 7 and did 2 plus 7, it would satisfy this coming out rational? Okay, why can I not pick the 2 and the 7? Because I also have to multiply them. Is 2 times 7 irrational?
No.
Okay, so does that make sense why I cannot use the 2 and 7? It works for multiplying to rational, but it does not work for adding to an irrational.
Can't you use
The radical one. So here's the thing. I definitely going to use the radicals, but, gentlemen, I need you listening. I want to use a set of radicals that when I add them together, what happens to the radicals?
they become irrational.
Do I want them or don't want them if I'm looking for a rational number?
You don't want them.
Okay, so the radicals should undo each other or cross each other out. So when I add what two radicals, would the radicals end up canceling each other out?
Yeah. No. Maybe so. We don't
Okay,
know.
square root of 7 plus what? Square root of 2. Are those going to undo each other?
You can do
No.
2 and the 7.
Okay, if I did root 7, okay. He said root 7 plus negative root 7. That would work, but do I have a positive root 7 and a negative root 7? And multiplying them wouldn't work either.
So,
Okay.
Can you use a rational number?
I will tell you, you could, but it's not going to work on this case. Root 7 and what?
Root.
I heard somebody say it.
2 root.
2 minus root 7. What happens if you add these together? What's going to happen with these two guys right here? They're going to cancel out, leaving behind what? And is that rational?
No.
And if you multiply them, root 7 times 2 minus root 7, you end up with root 7 times 2, which is 2 root 7, minus, does anybody remember what happens when you multiply a radical 7 by a radical 7? Without using 40, they cancel out, so you're left with just minus square root of 49, but square root of 49 is 7. Okay, multiplying them, did I get irrational right here?
Yeah.
When I added them, they undo each other and I end up with a rational. Okay, now we want to multiply it be rational, and when I add the same two numbers, it is irrational. Multiply rational, add irrational. If I'm looking for irrational in either of these, I'm definitely going to have irrational numbers that I'm picking. Now this time, when I add them, I need the radicals to save, but when I multiply them, I need the radicals to undo each other or cancel each other out.
So can you use the positive one now?
Okay, tell me what I want. For example, what's root 5 times root 5?
That's
5.
That's root 25, which is 5. You're right. So that's rational. What's root 5 plus root 5?
Root 10.
Be careful.
Root 5.
1 root 5 plus 1 root 5 is? Okay, when I multiplied these two, did it come out to be rational?
Yeah.
And when I added the two numbers, it came out to be
Irrational.
irrational. So I'm looking for something like this. I multiply, the radicals undo each other, but when I add it, the radicals stay. Where is that going to happen? Okay, root 2 with what?
With root 7.
If I'm trying root 2 and root 7, that's root 14. Is that a perfect squared?
Yeah.
I want them to either multiply to be a perfect squared or the radicals undo the way we know they're going to do. Root 7 is definitely one of them.
Okay.
There's only
2 root 7.
2 root 7. Okay. If I add them, what would that give me? 1 root 7 plus 2 root 7 is?
Root 7.
Okay, so where's the adding? Add and it's irrational. Did that work?
Yeah.
Okay, I don't have room to show the multiplying, so I'll do it here. Stop the talking. Root 7 times 2 root 7. There's a 1 here. What's 1 times 2?
2.
And then remember, without saying 49, what's root 7 times root 7?
7.
And did it come out to be rational the way we wanted it to? Yes. Questions?
So is that for C? 14?
That was for B. Okay, now we're finally on C. You multiply, it's irrational, and you add, it's irrational. That one's pretty easy. You just want to pick anything as long as the irrationals don't undo each other ever, adding or multiplying. Give me two of them.
2 and 7.
Root 2 and 7? Root 2 and root 7 would have worked. Root 2 times 7 is 7 root 2, irrational. Root 2 plus 7 is root 2 plus 7, that's still irrational. Would it have worked if you put root 7 and root 2?
No. Because that would be rational. Right? Wait, no, it is irrational.
What's root 2 times root 7?
Root 14.
Root 14, it's still irrational, right?
Perfect square.
It's not a perfect square, so it's still irrational. All right. Questions?
40 is not perfect square?
It's an even number. You can divide it by 2, but you can't square root it and get a perfect number. Yes?
Can you use the same thing twice for these kind of problems?
Mm-mm.
Just one time?
Mm-hmm. Well, you can use it here and then use it again here, but not twice in the same question. Like you can't use root 7 and root 7 twice
so
in the
you
same.
can't use it 3 times, only make twice?
Mm-mm.
Okay.
All right, gentlemen. So taking a look at 13, I'm going to give you guys a few seconds to go through and quickly decide which ones are false. A few seconds to try that on your own.
Oh.
Quietly, try them on your own. Which ones are false? There's more than one.
Let's use it. What's another one?
Okay. First one, true or false?
Oh, it's false.
False. Okay. What mistake did the kid make to get x to the 6 over x squared to equal x cubed? They divided. 6 divided by 2 is 3. Is that what they should do?
Yeah. Wait, no.
They should subtract.
I thought they did. Oh.
Remember those things I told you guys to add to the back so that you have it on test day, put it on your test as well? Subtract. Okay, next one, true or false?
False.
Oh.
False, why is it false?
Because 2 times 4 is 8.
Okay, because they didn't multiply is correct. What mistake did the student make?
They
Added, okay. Next one, true or false?
That is false.
False. What should we do when we have a negative exponent? Move it to the bottom. When we have a negative coefficient, it just stays. It does. We don't put it up to the exponent like that. So that one's false.
That one's true.
This one is true.
The rest of them are true, I think.
Okay. What about this one?
That one's a false.
It's a
False. What mistake did the kid make to
They
make
subtracted,
this?
or
They added
they
negative
added
5 plus 4 and got negative 1. Should we be adding here?
Now I gotta multiply.
Multiply. All right. Questions?
Yeah, no.
All right. I'm going to give you guys a few seconds to do 14. A, B, C, D, E. You're looking for all of those that are irrational, meaning when you clean it all up, there's no more radical in your answer. So clean them up, and there's no more radical. I'm sorry, you want a radical because it says irrational. You want the radical in your answer for it to be irrational.
Whereas, I feel like it's shorter. All the periods are kind of shorter.
They are short because we talked about this at the time and stuff. Can anybody tell me on letter A, is that rational or irrational?
It looks
Irrational.
rational.
I got irrational.
Okay, I heard it looks irrational, and I'll guess irrational. Why is it rational? Okay, when you actually go through and do the work, 3 times 5 is 15, and you multiply your radicals, what's 2 times 18? And what do you notice about root 36? It's a perfect square. So do you end up with a radical in your final answer?
No.
No. So this is rational. So not letter A because they're asking for irrational.
So it's not letter B, right?
Why is it not letter B?
Because that's a perfect square too.
Perfect squared, so no radical, so this is also rational. Okay, keep going. Remember, when dividing radicals, as long as both numbers have a radical, you can divide. Let this go well. It's so nice to see you. All right. Next one, Wendy. Rational or irrational? Okay, or let me take a step back. If before I ask that, how do I clean this up? What do we do?
Divide by 5.
Divide root 15 by root 3? Yeah, and what do we get? Root 5. Is 5 a perfect square? No. So rational or irrational? Irrational. Circle it. And then check the next one as well.
Why? You can't dab?
Yo, what kind of dab you talking about?
Regular or stylish? Oh shit.
The good kind.
Do the stylish one. Oh.
Do regular.
Yeah.
Do stylish.
Quick and. Bro, my phone is done broken. So I fucked one up and then I got a new one. I got
All right.
a replacement and then I messed that one. I was for like 6 months.
Okay,
It's over.
guys.
This can be irrational.
Okay, so this one's irrational. What about the next one?
It looks irrational.
Okay, let's check it. 4 is 4. When I change the 27, what goes here? 3 or 2? 3 and 2? Okay, is 27 a perfect cubed?
Yeah.
What's the cube root of 27? 3. 3 squared is 9. Is there a radical there, yes or no?
No.
So this is rational?
Rational.
Okay. Is root 2 a perfect squared?
No.
Is 18 a perfect squared? It breaks down. I will tell you that. 18 does break down, but it's not going to break down to a perfect squared, and this isn't a perfect squared either, so what's the answer? Irrational.
It is irrational.
Got it?
Yeah.
Okay. Flip over to the next page really quick. If you haven't done it already, you need to make sure you're finishing up Unit 9. What is tonight's packet? Which one should you be working on? What unit? Unit 12. Unit 12, I see you again on Friday, which will then do 13 and 14. Question? Right here?
Hey, we have 4 minutes left.
No, we got 2 minutes.
Guys, stop the talking, please.
I can't even read.